Water.
This is what you want. So, let's get it. Enough talk.
Water is so special, it is pretty much the fundamental basis of all life. And by the fundamental basis of all life requires water. And the reasons why exactly, though, aren't entirely too clear, because water does have some really, really interesting properties, and it can do some crazy things that I never even thought was possible originally. Like,
we expect droplets to coalesce instantly with the water.
And that is water droplets floating on the top of water, which is a little bit strange as to what exactly is going on there. And not only that, water is able to make a sort of bridge, which is pretty crazy.
And here's another example. 2 beakers of water, you put 2 electrodes in, and you put high voltage between them. And then what happens is a bridge forms. And this bridge is made of water, a bridge of water, and this bridge can be sustained as you move one beaker away from the other beaker.
So in this video, I will be explaining just why water is so unbelievably important, and not only that, a little bit why it's not fully understood, and a little bit more into the process of water, or how water can be a little bit related in oxidative phosphorylation. So first, let's start off with what exactly water is and what are the forms that it can be in. Well, water is supposed to be H2O, and the forms that it can be in are, as we learned in school probably, solid, liquid, and gas. However, there is a 4th form of water. Now, this form of water is not actually like the ones that we learned in school. In fact, it is quite different. Not only is the chemical structure different, it is not H2O, it is actually H3O2, which is a little bit strange. It also has the ability to form these little hexagonal structures, which is really important to what exactly this structured water is. And when water forms these hexagonal shells, it's not actually like regular water. It's not all liquid. It's sort of like a gel, and you can think of it, I guess, kind of like a toothpaste then, I guess. A little bit more viscous. When water has this hexagonal shape, it can actually prevent electrons from moving freely around, and that basically means you have more control over the electrons and how they are flowing. And this is very, very important. And we're going to talk a little bit about biochemistry and how this relates to biochemistry. Now, water also has some functions in biochemistry which are unbelievably important. Now, just some of the examples that water has in biochemistry specifically, it has to do with very unbelievably important functions that we've talked about before, such as metabolic function, enzyme function, DNA stability, protein folding and aggregation located in the endoplasmic reticulum, cell membrane integrity, immune system function, nutrient and waste transportation related to lysosomes, and organ and cell function. Now, every single one of these functions completely depends on water, and when water is lacking and there's basically dehydration, these functions are not as effective, and in the process, yes, it's sort of also like causing cellular damage. Now, the problems that it can include are metabolic disruption, impaired enzyme function, weakened DNA stability, protein misfolding and aggregation, increased oxidative stress, compromised cell membrane integrity, cell lysis, reduced immune function, impaired nutrient and waste transportation, and basically overall cellular and organ dysfunction. And if we want to increase exactly these things, which we probably don't want to increase because they cause more problems, then obviously, this is going to sound crazy, but drinking coffee, drinking soda, drinking juices, and a lot of these other things that are dehydrating are not helpful because they all increase this rate, and they all increase the rate of this occurring, and you don't want all of this cellular damage happening. You don't want the rate of this cellular damage occurring in the first place. Now, you might actually think that juices are hydrating, but they aren't, and that's because juices, actually, the sugar in them counteracts the hydrating effect in the first place. And I mean, if you look at the amount of sugar in juices, it is exorbitantly high. And I mean exorbitantly high. You can just compare what's in a regular fruit versus juices, and you'll see real quick they are ridiculously high. Now, remember that gel-like water that I talked about before, specifically the easy water? Well, this is where we're going to understand a little bit more on how exactly easy water works in biology. Now, easy water, when it comes to biology, actually forms that exclusion zone, the EZ, around little organelles in the cells, or it might even form it around the cell membrane. I mean, it is really important. And part of this can contribute to the proton gradient. Now, I've talked a little bit about the proton gradient in the process of oxidative phosphorylation a little bit before, but most likely one of the ways that the proton gradient is helping to be established is because of this easy water. It's because of the water itself. Now, there's another thing in particular which is really important about easy water, and it is exactly what allows for capillary flow to happen. Now, capillary flow is it is so important to biology. It is just, it's one of the most crucial parts of how we're even alive in the first place. Now, capillary flow is basically where the red blood cells are able to move through a tube, or in this case, the capillaries, and they are able to move quite freely and not exactly with any resistance for some reason. There is a little bit of resistance, but it's sort of free. There's almost like it's coming from no energy. Now, how is the red blood cell moving through the capillary with almost no energy? This flow can also be observed just in some basic physics experiments. Now, this brings us back to easy water. Easy water will basically form those exclusion zones around the hollow tube, whatever the hollow tube might be, and that is how you get your capillary flow. Now, that's a big deal, because if you're having blood pressure issues, or if you're having any sort of these things related to that, you might have heard like the whole term of, just go out in the sun because you'll feel less stressed. Well, this is quite literally what it might mean, because if we increase the energy specifically, then we're allowed to increase the exclusion zone, and increasing the energy means going out into light and exposing the capillary to light, or basically exposing the hollow tube to an increased amount of light, will allow for exactly that capillary flow to happen, except at a faster rate. So again, easy water is so unbelievably important. I cannot begin to describe, especially when it comes to capillary flow. It is pretty much what exactly allows it to happen in the first place. Now, back to why water is really important, especially when it comes to biology. Now, there is one thing in particular that is very picky with what it does and doesn't like to use, and that is the mitochondria. The mitochondria does not like to use deuterium, and this is where we're going to be talking about deuterium and where deuterium can be found, and why it's really important to decrease the amount of deuterium that you're exposing yourself to every single day, usually in your diet. Now, deuterium is basically just an isotope of hydrogen. So that means that instead of you having your regular hydrogen, which is 1 proton and 1 electron, instead deuterium is 1 proton with 1 neutron and 1 electron. Now, this does make a difference, especially when it comes to understanding kinetics and how chemical reactions occur. So this will be a little bit important in terms of biological reactions, especially, I think, and that has to do with forming reactive oxygen species, which we have covered before in my previous video on why you do not want glucose. Avoid it. Now, when your cells are going through the process of oxidative phosphorylation, they don't want deuterium, and when they do get deuterium, things can cause problems. And this is because what you're basically doing is you're taking 10 pounds and you're trying to stick it into a 5-pound bag. Now, can you do that? Maybe, yes, you can probably, but if you do it repeatedly, it won't probably work out so well, and the bag obviously is most likely going to break in the end. Now, there is actually a little bit more to it, and I don't think this is necessarily proved yet, but I do think that this is one of the contributors to reactive oxygen species being formed, and it has to do with kinetic isotope theory. Now I'm going to be explaining a little bit more on deuterium and why exactly deuterium is probably not so good, and that has to do with kinetic isotope theory. Now, I don't necessarily know if this is proved yet, but just from my standpoint or understanding of chemistry, this probably does cause some problems. So remember how I said that deuterium is a little bit heavier? Well, the thing is, when it's a little bit heavier, it also allows for the reaction rate to be slower. Now, this is kind of a big deal, and the reason is because when the reaction rate is slower in the process of oxidative phosphorylation, there is a chance that that deuterium, or more specifically, that electron is not exactly going to be in a spot that it should be. And that's because there's a higher chance for that electron to actually end up forming a superoxide, because there is a higher chance of it to stay in that intermediate state for a longer period of time. And that intermediate state is a really, really unstable state, to put it mildly. And that's exactly how that superoxide can get formed in the first place. It's because that intermediate can react with a oxygen and, well, more specifically an O2, and that will cause your, once again, hydrogen peroxide into, so again, not good. And that is exactly why deuterium is not what you want. Now, there is a little bit more to it, and we're going to be going over some foods and what exactly has deuterium in it and at what levels. Now, for starters, you probably might have guessed this already, but deuterium is actually found, once again, higher in plants than it is in animal products. Now, if you're really interested more in this deuterium stuff, I recommend you check out Laszlo Borosh, because he talks a little bit about this, but let's start with the food. So to start off on the high end, seed oils in particular are quite high when it comes to their deuterium content, and this is around 180 to 200 parts per million. And seed oils, specifically the ones I'm talking about, would be canola oil and sunflower oil. Now, next comes in the sugars and the starches. Now, sugars and starches are also quite high, and just to name some numbers, wheat flour comes in at 150 parts per million, beet sugar comes in at 146, corn comes in at 145, potatoes comes in at 143, and oats come in at 141. Next has to do with meat. Now, meat in particular has around 138 parts per million. Now, when it comes to the fatty acid content, we will be talking about the fatty acid content of both the plant and then again the animal meat. So afterwards, we have the vegetables and vegetable fats. So for instance, just one vegetable in particular, which does seem to be a little bit lower in deuterium, is spinach, coming in at 136 parts per million. The vegetable fat, peanut butter and olive oil, specifically peanut butter, comes in at 131, and olive oil comes in at 130. And finally, we have the absolutely lowest fatty acid in deuterium, and you probably guessed it, it's meat. Now, these meats, specifically the animal fats, would be butter coming in at 124, beef fat coming in at 121, and lard coming in at 116. Now, hopefully you learned exactly why all of this happens in the first place, and this whole process of oxidative phosphorylation, why it's so unbelievably important. Understanding the unbelievable importance of water, especially when it comes to capillary flow, and that in turn also means blood pressure, and also why the sun, for that matter, and light is so crucial to capillary flow and actually having good blood flow. Now, that is just when it comes to water. However, hopefully we also learned that not only are vegetable oils also high in polyunsaturated fats, which again make them more prone to lipid peroxidation, but also they have higher amounts of deuterium in them, especially when compared to animal fats. So once again, thank you for watching. I hope you learned something from this video. Let me know if you guys could actually follow along. If you're interested in more videos like this, then please let me know in the comments below. If you like the video, then please give it a like. It helps it a lot. And if you're interested in more science videos like this, then please subscribe to the channel, because I plan on making tons and tons of more videos, and maybe not always to this rigor and level of science, but also to more understandable aspects. And if you're interested in a particular video, please again, leave them, let me know in the comments below. So thanks for watching. I'll see you in the next one. Peace. And don't forget to share this video because I like this one a lot.